Hello and welcome to this video in which I will present my last project, which is email classification using NLP technology. So uh, this is our pipeline. So I start by importing the data, then do some data exploration, clean and pre-processing the data, divide the data into train and test part, create features, create the model, and last one is evaluate the model. So let's start with each step. First, I import all the library required to this project. So I import the library required for importing the data, for the visualization part, for the text preprocessing. I import the NLTK and regular expression. I import also word stemming. For feature extraction, I import count vectorizer. I will explain each one in details. And for the model, I import the naive Bayes classifier and random forest classifier. I import the data, and this is the data we have. So as we see, we need the value 1 and value 2 from the first data frame. So I take the first and the second column. I rename each one. The V1 will be label and V2 will be text. And this is the data frame after taking the first two the first two columns. So after I drop the duplicated rows for the exploration, so I display the dimension to the data frame. We have 5169 rows and 2 columns. Then I display the number of null values, so we don't have null values in this data frame. Then I display the values count for each type of label. So for the ham emails, we have 4516 email ham and 635 email spam. Then I add a new column named email length, in which they contain the length of each email. So the max length of email is 910 and the min length is 2. This is the distribution of the length of emails. So as we see, we don't have much data when the length is higher than 250. So for this reason, I delete all the email that length is higher than 215 and less than 3, less than 4. And this is the distribution of the new data frame. So after this first cleaning, the data frame is reduced to 5106 rows. After I display the word cloud to see the word more frequently presented in the corpus. So for the ham email, this is the word cloud. So we have will, we have got, love, come, now is the most frequently presented. And for the spam emails, we find stop, text, replay, mobile, now, call, and so on. So let's move now to the text preprocessing. First, I define a function. It will convert the text colon to lowercase and store the result in new column named text clean. Clean text. After I remove all the URL presented in this column clean text, remove all the punctuation presented, remove all the digit, the multi-spaces, and the single character. And this function will return the new data. So I apply this function to the data and store the store the result in a new data frame. After that, I remove the stop words. So, in simple words, stop words are the set of commonly used words in a language. Example of stopped words in English are the, is, are, and so on. Stop words are commonly used in text mining and natural language processing to eliminate words that are so commonly used that they carry very little useless information. So I down using NLTK library, I will download all the stop words. Then I specify the stop word for English, since our data is in language English. So this is example of stop words. We have me, my, myself, we, our, and other. Then I define a function named remove stop words. Specify stop words to be the English stop words, and then delete all the stop words presented in a text. Then I apply this function to the clean text colon. After that, I apply some text normalization. So text normalization can be done using stemming or limmatization. So stemming is a rule-based system to bring a word to its canonical form, like removing ing from dancing to form dance, or ticket to tick. As you can see, stemming might not produce a dictionary word all the time after normalization. For the limitizer, it's more intelligent system that keep a dictionary it on its side while normalizing word. So this is some example for the stemming. As we said, is remove the suffixes. So for the studies, it will be study, remove the es, and for the studying, it will be study. For the limmatization, both studies and studying will be study. To make it simple in this video, in this project, I use the stemming normalization. So I import Porter stemmer from NLTK and apply the stemming to each word presented in the corpus. So after finishing the text processing, let's compare the text before cleaning and after cleaning. So this is the text before cleaning. So as we see, we have punctuation, we have uppercases character. We have also stop words. So after the cleaning, all this character will be removed. As we see, this is the final output after the text preprocessing. And the final step for the preprocessing is convert the label colon from categorical to numeric. So the number one presented the spam emails and the zero presented the ham emails. Now let's move to the feature extraction. So the feature extraction is just convert the text data into numeric data. So I use the bug of words. This is the principle of bug of words. I use the count vectorizer, which is a function that creates a dictionary containing the occurrence number of a token. So this function will divide the text into words or tokens, and then determine the number of occurrence of each token presented in each row. So I apply the bug of word to the colon clean text and store the data into a new variable named X. So after creating the feature or extracting the feature, so we have 5106 rows and 6800 uh, 45 columns which presented the feature of the model. After that, I divided the data into train and test. So the X presented the features and the data, the column label presented the label of our model. Now let's move to the last part of this project, which is model training and evaluation. So for the model, I choose two models: a knife-based classifier and random forest classifier. So let's start with knife-based classifier. I initialize the model. I train the model using the training part, and then I display the accuracy for this model. So as we see, our model is accurate for 98%. After that, I do some prediction, display the confusion matrix. So the confusion matrix is a technique of evaluation the performance of the model. So it will show the number of true positive, uh, which is spam in the real world, and the model predicted also spam. It false negative, which is spam, and the model predicted harm. So it's error from the model. False positive, which is harm, and the model predicted spam, and true negative, which is harm, and the model predicted harm. So this is the confusion matrix for the knife-based classifier. So as we see, there are 838 spam, and the model predicted spam, and just two spam, and the model predicted harm. In the other example, we have 61 ham, and the model predicted correctly ham, and just 10 ham, and the model predicted spam. Another method for the evaluation of the model is report classification. So for the report classification, we have precision, recall, and F1 score. So for the precision is what percent of your prediction were correct. For the recall, what percent of positive cases did you catch? And for the F score, what percent of positive prediction were correct? So the formula for the precision is the true positive divided by true positive and false positive. So that's mean this number is divided into the sum of these two numbers. For the recall is the true positive divided by true positive and false negative. And for the F1 score, it's a fraction between the recall and precision. So it's 2 multiplied by recall multiplied by precision divided by recall plus precision. So as we see, for the 0, which present the number of the spam emails, so for the spam emails, the precision is 0.98, the record is 1, it's higher accuracy, and the F1 score is 0.99. And for the ham emails, the precision is 0.97, the recall is 0.86, and the F1 score is 0.91. So let's move now to the second model, which is random forest classifier. So I initialize the model, I train the model using the training part. I display after the model accuracy. So this model is accurate. So the accuracy is of this model is 97%. Then I display the confusion matrix. This is the confusion matrix, and this is the classification report. So if we compare the two model, we find that the naive Bayes for this data frame is more accurate than the random forest. So we have the accuracy of the random forest is 97%, and the accuracy for the naive Bayes is 98%. So let's summarize our project. I start by importing the data frame, do some data exploration. After that, I apply some text preprocessing like text cleaning, such as remove the punctuation, remove the URLs, remove also the multi spaces. After that, I remove all the stop words presented in the corpus. Normalize the corpus using the stemming method from the NLTK. After that, I do the step of feature extraction using the bag of words. And finally, I build the model using two models, which is a naive Bayes classifier and random forest classifier. For each model, I display the confusion matrix, the accuracy of this model, and the classification report to compare the performance of each model, and and after the comparison we find that the naive Bayes classifier is more accurate for this for our problem. So this is all for this project. I hope that you get the idea, and thanks for your attention.